G'day, how you going? Today we're going to be looking at triangle properties. Now in your textbook there are a whole range of triangle properties and we'll show you those first. Now I'll give you these on a sheet, but you should remember most of these anyway. It's certainly something you would have seen before. So obviously we know there's 180 degrees in a triangle, we just assume that. So part of what we're doing is proving some of these things for yourself so you actually understand what's going on. I'll show you these geometry packages inside class as well. The exterior angle is equal to the sum of the interior angles, so that's what the C and A and B are. We know that if we have an isosceles triangle that the two angles at the bottom are the same, and obviously the two sides are, that's the part of the proof of an isosceles triangle. Equal angles of a triangle, so if angles has two equal angles then the triangle is isosceles, so we know that. And obviously the perpendicular bisector with the isosceles triangle there. If we scroll down just a bit further here, the midpoint theorem. Okay, so the midpoint theorem, so if we're looking at two lines with a midpoint, if the sides of the triangle are parallel, the third side is half its length. Alright, so that's another proof there. And then converse to the midpoint theorem, the line drawing the midpoint from one side to the triangle parallel to the second side bisects the third side. In other words, these two sides, these two lengths are the same. Alright, so these are all proofs that you can actually do, and I think you've seen most of these anyway, but let's have a go at a couple of them just to get you into the mood of what you've got to do so you actually understand the process of what that involves. Alright, so if we were doing this first one, now it's obvious, we know what it is. We know that A plus B plus C has to be equal to 180 degrees, don't we? Alright, now, but it's about proving what's going on here. So I might do this in a red pen. Alright, so I'm going to extend this line here, because this line is parallel to the other line over here. I'm going to extend that line there, and I'm going to extend this line. That's a little trick that you use when you're doing proofs. Alright, so we know that this particular angle here, B, and for thinking about these sides over here, right, so we know that B and B here we know this angle here, B and B, are alternate angles. And we know A and A are alternate angles. Alright, so the Z angles are alternate angles. Alright, so we know that then obviously A plus B plus C is equal to 180 degrees. So just the working out that you need to show there is you need to show that angle, angle A, E, C and B is equal to B, and we know that angle D, C, A is equal to A, and we're going to call those alternate angles. Right, so that's a little thing there. And that's just simply by extending those lines. So then we know that A plus B plus C has to be 180 degrees because 180 degrees in a line. Right, and that's the proof. Right, so we're looking at the next one here. Use the figure to establish the interior angle of a triangle theorem. The interior angle of a triangle theorem. Right, so if we remember what that actually is, so it's this one here, the interior opposite angle. So the size of the exterior angles of a triangle is equal to the sum of the interior opposite angles. That's what we're looking to try and prove. Right, So again, we're using the idea of parallel lines, so we might go for our pen and we might just extend these lines here, extend that line there. Alright, so we know that that angle there has to be A, right? Why? So we know that angle EBD is equal to A, and it's an allied angle. Right? And then what do we know? We know that angle A plus C plus B must be equal to 180 degrees. Right? That's 180 degrees in a triangle. And so therefore angle CBE has to be equal to angle C. Alright? So therefore that has to be angle C in there. Don't we? Alright? So therefore angle CBD is equal to simply A plus C, which is equal to the external angle. Alright, so that external angle there is equal to the sum of the interior to interior angles over there. So I've actually proven that by using, again, some logic about angles. In question 3, you're given a triangle which has two equal angles, A and C. B is the midpoint of AC is located and BD is joined. Okay? Use the figure and the congruency only to prove the equal angles of a triangle theorem. So if we come back to here, this is the one we're trying to prove. If a triangle has two equal angles, then the triangle is isosceles. So we have to prove it's isosceles. So two isosceles triangles, an isosceles triangle has not only the angles at the bottom equal, but the two sides on the thing are equal as well. So that's what we have to try and prove here. Now, we know we have a common side there. So we'd say BD is common to both triangles, which is what it is. We know that if we've got side-side corresponding angle, so from our previous work that we've done with similar triangles, we know that these are our proofs. Okay, so if we have the same thing over here, now probably the one that we probably need to use is, well, we can't use a side, and angle because it's not between the two. That's true, isn't it? Right? But what we can do is we know that when a line bisects a particular thing over here, we know that it hits at a right angle there. Okay, it has to hit at a right angle when it bisects those two things. Right, so we need to say a statement like that. So BD bisects AC, so therefore angle DBA equals angle DBC, which is equal to 90 degrees. Alright, and so therefore the fact that we actually have that is 90 degrees, which means that this angle here has to be equal. Alright, so therefore all angles equal. got all angles equal, what we do have is we have angle corresponding side. So therefore, congruent triangles. So if they're congruent triangles, therefore we can say that AD is equal to CD, as they are corresponding sides. So therefore, triangle is isosceles. Alright, so an isosceles has two sides are equal. So that's the proof there. Now these are hard because, you know, they're pretty obvious, most of them. So that's the hard thing about them. Alright, so we'll leave the video here. I want you to have a go at trying to prove some of these things in exercise 3C. Thank you.